Farmers rely on the good old squeeze test to figure out if their soil is sandy, silty, or clayey. What if those labels barely scratch the surface of your soil's true potential? What critical factor are we all overlooking, and how can it transform your crop overnight? The answer lies in what's alive beneath the surface. Biological activity is the missing key. While soil texture gives you part of the story, microbes unlock the rest. So if you've done the squeeze test on your soil, if it falls apart quickly, you've got sandy soil. If it clumps like dough, it's clay. And if it's somewhere in the middle, welcome to silty soil. Simple, right? But while that test tells you how the soil feels, it only scratches the surface of what's really going on and why some soils do better than others. Farmers like using those categories, sandy, silt, and clay, because they're straightforward. Texture affects water, air, and nutrients, so it makes sense to start there. But focusing just on texture can lead to frustration when your crops don't thrive the way the soil type suggests they should. That's because there's a bigger piece of the puzzle missing: how biologically active your soil is. Without strong microbial life, even the most balanced, textured soil can come up short. Take clay soils, for example. They're loaded with nutrients, but they have a compaction problem. That dense structure traps water, starves plants' roots of oxygen, and stunts growth below the surface. Then you've got sandy soils on the other end of the spectrum. They drain beautifully, but lose water and nutrients almost as fast as you apply them. It's like trying to grow crops in a sieve. It's just not built to hold on to the good stuff. Silty soils might seem like a sweet spot with fine particles that hold water well. But the downside is how easily those particles can hang onto too much, causing nutrient stagnation that leaves plants starved for what they need at the right time. This is where biology changes everything. Think of microbes as tiny soil engineers. In clay, they loosen up that compact structure, helping air and water move into the depths. In sand, they almost act like glue, holding water and nutrients where roots can actually get to them. And in silt, they regulate the release of nutrients, shifting the balance between too much and not enough. Research backs this up. Studies consistently show biologically active soils cycle nutrients faster, suppress diseases, and use water more efficiently. The question isn't just what texture is my soil. It's how alive is it? That's the game changer. Picture this: your soil, no matter its type, has a progress bar slowly filling up. Moisture, nutrients, biology, all improving step by step. And it all starts with the right microbes matched to your soil's unique challenges. Let's break it down. Sandy soils, for example, are like a leaky bucket. Water and nutrients pour right through, leaving plants dry and hungry. The right microbes act like a sponge inside that bucket, helping retain moisture and nutrients. Essentially, they create a slow-release system for plants, ensuring roots aren't left high and dry after a rain. This doesn't just make sandy soils a little better, it reframes how they perform. Microbes take a system built for loss and turn it into one that holds some of the good stuff for longer. Now think about clay soils, dense, tightly packed bricks. Nutrients? Sure, clay's loaded with them. But roots struggle to breathe, and water pours and stagnates, and compaction slows everything down. That's where microbes come in, creating pathways, tiny tunnels that let air and water get deeper into the soil. Over time, this loosens up clay structures but keeps its ability to hold onto nutrients. Essentially, microbes help shift clay from a growth barrier to a growth partner. Silty soil has its own quirks. It's good at retaining water, but sometimes too good. Nutrients can stagnate, trapped in a system where plants can't quite reach them at the right time. Here, microbes regulate the flow. It's not just about adding or removing. It's about keeping things steady and predictable for crops. Here you can see the impact of matching the right microbes to the environment. Instead of throwing a one-size-fits-all solution at your soil, it's like putting together a custom crew. Each microbe is selected to tackle specific imbalances or challenges, ensuring your resources are used where they'll count the most. And just like the progress bar, the soil gets better with time. Nutrients, moisture, and plant health ticking upwards steadily, all thanks to the biology below the surface. You can't change the texture of your soil. Sand stays sand, clay stays clay. But here's the good news. That doesn't lock in how your soil performs. The key is biological activity. Think of it like upgrading your soil's operating system. Microbes cycle nutrients, retain water, and suppress disease. Without them, even fertile-looking soil can struggle. Research has shown that biologically active soils outperform those with the same texture but fewer microbes. This isn't just about boosting yields, it's about creating a soil ecosystem that lasts. Healthier crops, better water use, and long-term sustainability. Now, that's worth thinking about, isn't it? It's grow time.